Solving with double angle identities, this is example number 2. Here we have sine x plus sine 3x is equal to 0. So we're going to try and get where we have just sine x's over here so that we can solve. So starting out, I'm going to look to replace sine 3x using our sum and difference identities. So I'm going to rewrite this as sine x plus sine of x plus 2x so that we can use those sum and difference identities. So I'm going to bring down here sine x, and now we're going to replace sine of x plus 2x using our sum and difference identities, and we have sine of the first angle, which is x, times cosine of the second angle, 2x, plus cosine of the first angle, x, times sine of the second angle, 2x. That's equal to 0. Well, now we have a cosine 2x up here we have to worry about, and we have a sine 2x. And we can use our double angle identities to replace those. So I'm going to first bring down sine x plus sine x. That's going to be multiplied by, and now with this cosine 2x, because I have 3 choices, again, I want to end up in just sines. So we're going to replace that with 1 minus 2 sine squared x. Then here I have plus cosine x. And that's going to be multiplied by the replacement for sine 2x, which is 2 sine x cosine x. All right, so we are going to combine our like terms here. So we have sine x. Before we can combine like terms, I apologize, we need to distribute. Sine x is going to be multiplied into the parentheses here. So we get plus sine x minus 2 sine cubed x. And then again, we're going to distribute cosine x over here, and that's going to be plus 2 sine x cosine squared x. We still have one more cosine that's hanging around here that we're going to need to look to replace so that we have all sines and we can start to factor. So we're going to, up here, we're going to combine our like terms of sine x and sine x. So we have 2 sine x minus 2 sine cubed x plus 2 sine x, but we're going to replace cosine squared x with our Pythagorean identity of 1 minus sine squared x. It's our last distribution here, where we're going to have to distribute this 2 sine x into the parentheses over here. All right, so we have 2 sine x minus 2 sine cubed x plus 2 sine x, and then 2 sine x times a negative sine squared x, we get negative 2 sine cubed x. All of this, again, remember, is still equal to 0. All right, so here we're going to combine some like terms. I see we have 2 sine x and 2 sine x. That's going to give us 4 sine x. And then we have negative 2 sine cubed x and negative 2 sine cubed x. So we have negative 4 sine cubed x. This is still all equal to 0. Now, we have something that we can factor out here. And when I look at this, I notice that they both have 4s and they both have sines. So we're going to factor out a 4 sine x And you're going to be left with 1 minus sine squared x. And that's going to be equal to 0. All right, we know from factoring and from our algebra that we can now, using the zero product property, set each factor equal to 0 to solve. So I have 4 sine x is equal to 0, and I have 1 minus sine squared x is equal to 0. Well, on the left over here, 4 sine x equals 0. If we divide both sides by 4, this says sine x is equal to 0, or x equals the inverse sine of 0. Or where on the unit circle do I get a value of 0 for y? We get that at 2 places. We get it at 0 and we get it at pi. So far we have 2 solutions, 0 and pi. Next, we go over here to the right, and I need to get sine on a side by itself. So I'm going to go ahead and add sine squared x to both sides. And here we get 1 equals sine squared x. To get rid of my squared, we know we need to take the square root. So when you take the square root, I should get 2 answers. I'm going to get the positive or the negative 1, and that's going to equal sine x. And because here I'm looking for an angle again, that says x equals the inverse sine of positive or negative 1. Or where on the unit circle do I get positive or negative 1 for y? So we get that at 0, pi over 2, three pi over 2, and this includes our all of our angles. I started to put them all together. Our solutions all together here are 0, pi over 2, pi, and 3 pi over 2. So 0, pi over 2, pi, and 3 pi over 2 are our solutions here.